example here. Okay, this one says, according to the International Telecommunications Union, ITU, 75.23% of people in the United States were using the internet in 2017. The national broadband provider believes that a larger percentage of people in the United States actually use the internet than reported. Suppose that the company conducts a large, simple, random sample of people in the United States. Of 8,573 respondents, 6,558 people indicated that they use the internet. Use a hypothesis test to determine if the company can be 95% confident that their claim is correct. So, what's the company claiming? This says the broadband provider believes that a larger percentage of people use the internet than reported. So the reported number was 75.23%. If they think it's larger than that, then our alternative hypothesis will be that P is greater than 75.23%. And if we rewrite that as a decimal, we'll say P is greater than 0.7523. And our null hypothesis would be that P equals 0.7523. Right? Again, we're testing for a proportion, so that's really all we need to know. And then we need our significance level. This one again gives us confidence instead. So it says if they want to be 95% confident, so to get significance, we subtract that from 1. We'll have 1 minus 0.95. That will give us our alpha of 0.05. And we can fill into our formula. So we know P is going to be 0.7523, so we can go ahead and fill that part in. 0.7523 over the square root 0.7523 times 1 minus 0.7523. And then we need P hat and our sample size N. Okay, so for P hat, we look at our sample data. Sorry. Okay. So we had 8,573 respondents in our sample, so that is N. 6,558 of those said they use the internet. Those are the ones we want to count. So for P hat, we'll have 6558 divided by 8573. Let's see what we get there. Get a long proportion here again. So let's just go 3 decimal places to be fine. It doesn't tell us, so I'll do 0.765. I think that's what Hawks usually lets you do. So, okay. So 0.765 for P hat. And N was 8,573. So let's see what we get out of this thing. Okay, 0.7523 times 1 minus 0.7523 divided by 8573. I got 2.72. You got 2? Good deal. All right. And it would be slightly, maybe slightly larger if we kept more decimal places. All right. So then last step, we want our p-value. So we look back at what type of test we're doing. What kind's this one? Right tailed, we have greater than symbol that points to the right. So this time we want the area to the right of our test statistic. If we want the area to the right of 2.72, what do we look up? Yeah, we look at negative 2.72. Let's see. There I get 0.0033. Our alpha was 0.05, so we can make our comparison. So 0.0033 compared to 0.05. What's our situation? Our p-value is less than, is smaller than our alpha. So then our conclusion is we reject the null hypothesis. P-value is low. So it looks like, according to our data, we've got strong evidence that the proportion was greater than whatever the number was, 72 something. What was it? 75.23%. Now, weakness of hypothesis testing again, we can say that we have evidence that it's greater than some number, but we can't say what the number is. Questions on that one? Okay, that's the last one then. That's our last hypothesis test we had to do, other than when we review for the test. Okay. All right, so if you